Hey guys, Jacob Howard here, creator of FPV Unlocked. Thanks for tuning into this free training on getting into FPV. Just a quick FYI, this is not a live webinar. We feel we miss way too much information when doing live presentations, and we want to make sure you get as much value as you can in the next 60 minutes or so. If you guys have any questions as we go, feel free to send them to me at jacob@fpvunlocked.com or message me on Facebook at m.me/FPVunlocked. Myself or one of our mentors will get back to you as soon as we can. Let's do a quick overview of what this training will look like so you guys know what to expect. First, I wanted to tackle the biggest questions I get asked about FPV, and that is how I got started in it and how I got to where I am today. After that, I'm going to talk about what FPV Unlocked is and why I created it. Then we are going to give you a sneak peek at some of the content inside FPV Unlocked by bringing you through your first steps of knowledge into learning all about what FPV is and what you need to know to get started. As a little bonus afterwards, I'll be giving 5 tips on getting started and developing in your skills in FPV. And then, if you guys are okay with it, because I'm giving away so much free value in this training, I'm going to make an exclusive offer at the end for anybody who wants to really dive into learning FPV beyond just this free training session. And to close it out, I'm going to answer a long list of most frequently asked questions about FPV. I've talked with thousands of pilots and those who want to start in FPV, and I've compiled the biggest concerns and questions they have with FPV. But before we get started, let me address 2 pressing questions first. Number 1, who is this training for? This training is geared more towards beginners and intermediates in the FPV world. It will also help professionals who have been doing it for years by providing them a new perspective and tips on getting better at FPV. Basically, anyone who's looking to get into FPV or expand their skills. The main goal of this training is to give you a better understanding of what FPV is and what the process looks like from terms to hardware needed and how to keep your head on straight through all the lingo and abbreviations you are definitely going to encounter. Number 2, how long is this training? This training is about an hour long. And don't worry, I won't be pitching my course the whole time. I'm sharing a ton of valuable information about the FPV world that would normally take days or weeks of research to learn. Definitely make sure you are ready to take notes because I won't be going slow and every minute will be jam-packed with valuable information. So, let's begin the training. First off, a little bit about our team at FPV Unlocked. My name is Jacob Howard, I'm based out of northern Utah, and I have spent about 5 years flying every type of drone you can imagine. From the DJI Inspire 2, Mavic Pro, Xylo Freakstyle, the Emax Hawk Pro, and many, many more. This is one of my favorite aspects of being in the drone industry, and that is flying all types of drones and having incredible experiences and views. The other main mentor in our course, McGregor Card, has been flying FPV since 2009 and was the type of guy who would attach an old camcorder to the bottom of his RC plane in order to capture footage. Because back then, they didn't have fancy things like action cameras or gimbals. He is the brain behind the course information we teach, and he has taught me a ton since starting work with him. Some of the brands we have worked with over the years include Race Day Quads, Emax USA, and several other companies across the country. In a nutshell, McGregor and I have put in the time, trial, and error to be able to teach you what to do and what not to do when getting into FPV. So, let's dive in. How did I get started? I get asked this a lot because most people who want to get into FPV don't know where to start. That's probably why you're here in this training. Well, I got started in FPV much like many of you. I saw some incredible FPV shots online and was hooked. I already had a videography company, so I thought this would be a great addition for my clients. But then I ran into the problem we all face getting into FPV. I did a bunch of research and was just appalled at how hard it was to learn. If I asked what frame to buy, I got hundreds of different answers with abbreviations and vocabulary I did not understand in the least. If I Googled something, it was accompanied with all kinds of stuff I had never heard of, and trying to wade through the information was unbelievably daunting. So I went a different route, bought a ready-to-fly FPV drone, and eagerly waited for it to arrive. I was smart enough to meet up with some new FPV buddies, McGregor Card included, on my first flights. I had put tons of practice in on a simulator with my PS4 remote, and my first flights went really well, as you can see from the DVR footage. However, soon after this, on Christmas Day, I decided to take my toddler and show him the drone. I flew about 2,000 feet away towards a mountain, lost connection to the drone, and it plummeted from the sky into the canyon, never to be recovered again. Over $600 gone. This shocked me, and I nearly gave up on FPV altogether. However, through the help of some FPV friends, I got back on the horse and decided to not make the same mistakes I did the first time. I decided to really learn FPV. So I spent the dozens of hours needed trying to find useful information and weed through the opinions online. It was exhausting, but fortunately I had good friends who knew FPV, such as McGregor Card, who helped me out and got me back into it. Then, as McGregor and I continued to work together, we noticed a growing need. There was no structured, organized way to learn FPV for beginners, intermediates, or even professionals. There wasn't anything to help new people get into it without experiencing similar issues that I had faced, such as losing money and time. So we started to do some research. I started talking with big brands such as Race Day Quads and Emax USA, and then we talked to thousands of FPV pilots and asked them what they would need if they could have an online course that taught them everything about FPV. We got over 400 pages of responses in mere days, and we started working like crazy with businesses like Emax USA and Race Day Quads to create an online course that would cover everything new and experienced pilots wanted. Thus, FPV Unlocked was born, a course containing currently over 70 videos and 7 hours of content organized to teach you FPV from beginning to end in the most organized and headache-free way possible. This includes what FPV is, what your different components are, what to buy and where, how to assemble and configure your drone and controller, flying your drone, tuning it to perfection, and much, much more. Currently over 7 hours of content, and we always add more to keep the learning relevant and up to date. So that's just a quick look at how FPV Unlocked was created. I tell this story to show you guys that I know what it is like and where you are coming from when trying to learn FPV. It is a very steep learning curve, and trying to navigate the hours of useless information to get little nuggets of golden information is utterly exhausting and a huge demoralizer. That's why we created FPV Unlocked, and I will talk about the full program at the end. For now though, let's dive into how you can start navigating the rapids of learning FPV and give you a solid base for continuing to learn. We are going to go in depth into things as much as we can with the time we have, but from here on out, the goal is to give you the knowledge you need to, at the very least, understand what goes into FPV and how you can learn it. So get ready to take notes, and let's begin with what FPV is and what it all consists of. First-person view flying, or FPV as it is more often called, can apply to lots of different technologies and experiences. The term FPV can cover everything from RC airplanes, helicopters, VR, and even cameras. But in this training, we are going to use the term to describe FPV in regards to the quadcopter or droning world. Also, for simplicity, we're going to call multirotors, quadcopters, hexacopters, and any other aircraft you would see in this training drones. Now, with that said, let's touch on a little of the history of FPV. The idea of piloting an RC aircraft with a camera as a whole started gaining popularity back around 2009 and was done mainly on fixed-wing aircraft. A lot of the equipment was homebrew and hand-built, early developments were bulky and not very intuitive, and oftentimes the video footage you got was very shaky and low quality. But hobbyist pilots enjoyed exploring the direction this new idea could go, so they became instrumental in pushing the development of the hobby even further. Over the last 11 years, the technology has progressed by leaps and bounds. Nowadays, you can purchase pre-built aircraft that are designed around FPV camera systems and high-definition video recording. Drones have seen the largest and fastest development and have become the main aircraft of choice for FPV flying. Their agility, speed, and ease of use are unmatched by other RC aircraft. With only 4 moving parts, they are relatively easy to maintain and with some basic skills easy to repair. Now, serious FPV drones are not the kind of drones you see at Walmart or on Amazon. Those look like this, and we like to call them stabilized drones. They rely on GPS and other sensors to fly stable and require little input to keep them in the air. FPV drones look more like this guy. It requires much more input from the user to keep it up and flying, and therefore much more goes into making and flying them. But what are the main differences between the two, and why would you go into the much more challenging hobby of FPV droning versus stabilized droning? Well, stabilized drones, the ones that a good portion of the country owns, are meant to be user-friendly and capture video or photos in an easy-to-use way. They also offer things like 4K or 8K cameras, customizable payload structures, GPS abilities, and live feed that goes to a connected phone or tablet. However, in the event of a crash, most of these drones were not designed to be repaired by the user. This can make for costly and lengthy repair times, taking you out of the action when you would rather be flying. Besides that, FPV drones offer a new perspective in the sky that stabilized drones cannot. This comes in 2 ways, with the camera and with the drone. Let me explain. A stabilized drone usually has a gimbal that holds the camera. As you move the drone about, the gimbal moves the camera so that it stays stable, level, and smooth every time. FPV drones do not have gimbals to keep the camera level, stable, or smooth. Instead, you get to have a first-person view of what your drone is doing as if you were flying right with it. This is where how the FPV drone flies makes the biggest difference. An FPV drone lets you explore and move about freely in the air. You can dive, loop, flip, roll, and speed down tracks, mountains, or raceways. The creative freedom you get with FPV drones just can't be matched. But how can an FPV drone fly so differently from a stabilized drone? It all comes down to yaw, pitch, and roll. Yaw, pitch, and roll describe 3 of the 4 main movements a drone can do. The other one is ascend or descend. Yaw controls the direction your drone is facing. Pitch is the forward and backward movement of the drone, and roll is the left to right movement. In stabilized drones, you have a limit on how far you can roll and pitch your drone. In FPV droning, you do not. You can do front flips, back flips, side flips, and a whole lot of other stuff because there are none of those limits. Here's an example of how a stabilized drone does a yaw and roll to the right with pitch forward. And here's an example of an FPV drone doing a yaw and roll to the right with pitch forward. Now, flying stabilized drones might seem like a total waste to many FPV drone pilots and vice versa, but in reality there are just two different tools for different work and end goals. Stabilized drones can get amazing cinematic footage in incredible quality and are used in many movies nowadays to capture aerial footage. On the other hand, with FPV drones, where most of the interest is in racing and freestyle flying, these things are not as important. Being able to fly 80 miles per hour through rings on a track or do triple backflips down a mountainside can still yield incredible footage, but most of the time it is done more as a sport than for business or capturing professional grade footage. It is important to note, though, that the cinematic side of FPV is growing rapidly. Let's go over briefly what a FPV drone looks like and consists of. We will dive deeply into each of these components throughout this video. The basic components of an FPV system are the quadcopter frame, motors, the propellers, a small FPV camera, video transmitter, video receiver connected to FPV goggles or viewing screen, flight controller board, electronic speed controller, battery, radio receiver, and last but not least, a transmitter to control it all. There are also several other things like antennas, beepers, and even lights to give your drone a unique look. Now, I know that seems like a lot to take in, but don't worry, we will break it down in this training. This will come in very handy down the road when doing maintenance and repair on your drone. First, let's look at FPV frames, the backbone of your entire drone. A frame for FPV drones has to be the right size, durability, shape, and weight to give the best results to the pilot. Frame size can be based on one of two things, prop size or how far apart your motors are. So, a frame could be defined as 210mm, or you could have a different frame that is referred to as a 5-inch frame. One refers to how far away the motors are, and the other refers to the prop size. When looking for a drone frame, it's good to keep in mind what your end goal is. If you want to get into racing, there are certain frame attributes to look for, like it being lightweight and aerodynamic. If you wanted to get into freestyle or cinematic flying with an HD camera on board, you're going to want a durable frame with the space to put a camera mount on. Carbon fiber is the most common material used for FPV drones. It's made of high-strength carbon strands that have been woven together in sheets that are then bonded with epoxy. Carbon fiber allows rigidity and high strength while still being lightweight. However, it can be expensive. Also, carbon fiber is conductive and can block radio waves, so care must be given while assembling and placing antennas to avoid short circuits and ensure you get good radio signals. Even with these drawbacks, it's still the most popular material for FPV frames. Frames come in lots of different shapes and sizes, the main shapes being X and H with a few variations on both, such as the Hybrid X, Stretched X, Dead Cat, and the True X. Each style of frame has advantages and disadvantages. Some, like the Dead Cat frame, will help to keep props out of view of your FPV and HD camera. Others, like the True X or Stretched X, have different centers of gravity and are better for racing. Hybrids are used more for freestyle and cinematic flying. Most frames consist of a top and bottom plate, arms, standoffs, and hardware to hold them together. There are frames that have all these pieces separate, and there are others that have unibody designs where some of the parts are integrated into one solid piece, or unibody. Battery placement is largely determined by what kind of frame you get. Most racing frames will have the battery slung on the bottom. Freestyle frames normally have the battery mounted on top of the frame. Pods are a canopy normally made out of 3D printed material, molded carbon fiber, or manufactured plastic. They are used to cover the sensitive components of your drone and offer protection from moisture, dust, and debris. However, they are not as strong as a frame with a top plate. Some designs also might limit airflow to the electronics, causing them to overheat. In the end, frames are another part of the drone that really determines how you can fly. Use the knowledge you just gained to discover exactly the frame you need. Let's jump into motors next. Selecting the correct motors is key to obtaining the right performance for your drone. Motors can be optimized for long-range efficiency, racing, freestyle tricks, tiny whoops, and much more. Using the wrong type of motor can lead to underperforming quads and maybe even ruining sensitive components of the drone, costing you money. In a nutshell, motors rotate your propellers to create movement. They are typically made of aluminum, steel, titanium, or even a combination of these. There are two types of motors used in virtually all drones, brushed and brushless motors. Brushed motors typically look long and cylindrical and are normally fairly small. Their uses in drones have decreased over the recent years and were much more popular in the past. However, they are still used and for many reasons are well suited for micro drones like the Emax EZ Pilot. Brushless motors typically have a short and wide cylindrical shape and can vary greatly in size. As their name suggests, brushless motors do not make contact with the magnets. This prevents the motor from wearing out due to friction between the brushes and the magnets, which increases the life of the motors greatly compared to brushed motors. Drone motors come in various sizes for different applications. There are a few important numbers to understand when selecting motors. Just like with props, drone motors have an identifying number system of 4 digits to indicate their size. To use an example, we will look at the Emax Pulsar 2306 motors. The number 2306 describes the size of the stator, the first two numbers 23 referencing the diameter in millimeters, and the second two 06 referencing the height. So for these motors, we have a stator of 23 millimeters in diameter and 6 millimeters tall. These numbers will also give you a feel for how heavy the motor is. The larger the motor, the heavier it will typically be. The smaller the motor, the more nimble it will be, but the more power it'll draw to keep your quad going. The second number used to identify motors is the kV. Motor kV is a number which identifies the constant velocity of a motor. It is measured by the number of revolutions per minute, RPM, that a motor turns when 1 volt is applied with no load attached to that motor. Your battery and your motor kV play an important role together. For example, if a 2400 kV motor is used on a 4S LiPo battery, which has a nominal voltage of 15.2 volts, the motor will spin a max RPM of 36,000 without a load. But if we pair a lower kV motor, for example a 1600 kV motor with a 6S LiPo battery, nominal voltage of 22.8, the motor will also spin a max RPM of 36,000 without a load. It is essential that motors are carefully selected with adequate specifications for their application. Let's look at the next aspect of flight, the props. Props are probably one of the most underrated and underthought of part of the drone, even though they are one of the most important. A bad or misused prop can drop your drone from the sky, give you shaky footage, drain your battery, or fry your motors. It is very important to have the right props for your drone. Props for drones come in many shapes, sizes, and materials. They can range from 2-inch props with 2 blades to 7-inch props with 3 blades. The two components of a prop are its hub and blade. The hub is the center part here that mounts to the motor of your drone, and the blade is the part that protrudes out and performs the rest of the work. No matter the prop's size, shape, or material though, its primary function is to provide the drone with its thrust or lift. On a drone, the props spin clockwise and counterclockwise and act like something called an airfoil. An airfoil creates areas of low air pressure above it and areas of high air pressure below it. This allows the prop to move away from the high pressure areas into the low pressure areas, creating thrust. You will notice when looking for a drone prop, you will see some numbers accompanying each one. This usually looks something like this, with Y representing each number. Each of these numbers reference a particular specification of the prop. For example, the first number is the size of the prop, in this case 5 inches. The second number is the pitch of the prop, like 5.3, and the last number is how many blades it has, such as 3. This is done to help you identify your prop as quickly as possible. The size of your prop will directly affect everything from thrust, responsiveness, and to how the drone grips and controls itself in the air. For example, a larger prop will generate more thrust and have better control in the air since it has a larger surface area and will respond better to direction changes. It also allows for dives and throttle drops to feel smoother, as the drone will have more air resistance coming back down to earth. Smaller props, on the other hand, will respond faster to input since they have less resistance and are more efficient at accelerating. Smaller props will allow your drone to more easily change altitude, which can be a good thing if you are racing through obstacles or race courses. Blade configuration refers to how many blades are attached to the hub of each prop. Props can have several blades on them, but the most popular ones have either 2 or 3 blades, also called biblades or triblades respectively. Pitch is often referred to as the angle of each of the blades on the prop. Although there are many factors besides the angle of the prop that change pitch, the angle is usually the biggest contributor. When a revolution is put on a prop, the pitch determines how far it will move forward. Now you can probably see right away that a higher pitch prop is going to give you more speed, and you'd be correct, but it sacrifices other things. A high-pitch prop gives you more speed and thrust, but less low-end torque. Imagine if you had your bike set to a high gear. It is great for speed, but not as good at giving that extra push on difficult terrain or quick turns. High-pitch props also respond to input slower and use more of your battery power. Low-pitch props sacrifice some speed and thrust to have that low-end torque, like switching your bike to a low gear to get that extra power and control. Low-pitch props will also respond quicker and be able to make tighter turns and movements. A thing to remember when learning and looking into props is that no matter what you pick, you are going to compromise somewhere. Every option for size, shape, configuration, or material is going to have different pros and cons than a different option. Sadly, there isn't a perfect prop for any drone. You just need one that does the best job for what you need. Next, let's go into some of the electrical aspects of an FPV drone, starting with the flight controller. The flight controller contains the primary processor which controls the general functions of all other components. A schematic diagram like this one of a flight controller will quickly show you why the flight controller is often considered the heart of the drone. Flight controller boards contain microprocessors and other various sensors in order for them to function properly. The flight controller essentially facilitates communication between all other components and tells them what to do. A few things that the flight controller is responsible for: on-screen display or OSD settings. In most drone builds, having OSD capabilities in the flight controller is standard. This gives you readings and information about your drone projected onto the screen in your goggles, so you can monitor different aspects of your flight in real time. Gyro. One of the sensors that are present in all flight controller boards is called a gyroscope, or gyro for short. A gyro is a microchip that records the speed at which a quadcopter rotates in each axis. Using this data and programmed mathematics, the flight controller can estimate the distance a quadcopter has rotated and whether its rotation is accelerating or decelerating. Accelerometers. This sensor chip can detect the acceleration of your drone in the roll, pitch, or yaw axis. This includes the force of acceleration of gravity, which the accelerometer uses to tell the flight controller how to stay level with the horizon. Some flight controllers also contain other sensors like barometers or current sensors. Most newer flight controllers will also have an integrated power distribution board to save on space in your build. The main brain of the flight controller is called the microprocessor. There are various types of processors available. These are differentiated through a simple rating system, and each processor is marked with a value between F1 to F7. The number after the F indicates the speed and functionality a processor is capable of. The most common ratings you will see today are F4 and F7. For a simple racing drone, a F4 processor will work just fine. But if you are building a more complex drone with an integrated GPS system, for example, a F7 processor will be extremely valuable. Flight controllers are typically placed in the stack, which is at the center of the drone on 4 standoffs. For 5-inch builds, the spacing will typically be 30 by 30 millimeters. However, another common size is 20 by 20 millimeters. For smaller drones, custom size and shaped flight controllers will be available. It is generally advisable to place the flight controller at the center of the drone to ensure optimum performance. This helps the flight controller record the cleanest data from the accelerometer and gyro. Most flight controllers will have at least the following connections: video out for a video transmitter, video in for the camera, electronic speed controller signal pads for each motor, and universal asynchronous receiver transmitters, or UARTs for short. For our purposes, UARTs are one transmitting and one receiving signal connection. It is important to understand UARTs because you will need to make sure there are enough for your purposes. One UART will have to be taken by your receiver for controlling your drone, and one is usually taken by video control or smart audio. If you are planning on using a GPS module, you will need one more UART designated for that. Let's look at power distribution boards, or PDB, next. These are slowly being phased out of FPV drones, but it's good to know how they work in case your build requires it. Understanding the very basics of a PDB is pretty simple. In a drone, there are multiple components that require power: camera, video transmitter, receiver, flight controller, etc. And each of these have a power requirement. For example, most flight controllers can handle the full voltage of your battery, but many cameras can only accept up to 5 volts. If you were to use the full voltage from your battery to power these components, it would fry some of them, which would make them unusable. For this reason, it is vital to be able to regulate this full battery power and distribute specific amounts of voltage and current throughout the drone. This is the purpose a PDB fulfills. Having a clean and stable source of power is extremely important, not only to protect components from failure, but also to prevent electrical noise. Noise in this sense is referring to an unwanted disturbance in electrical signal. Excessive noise can result in losing connection to your drone or very poor video signal. This noise often comes from the large amount of electrical power being drawn by the motors. If an appropriate PDB system isn't in place, this flow of current can interfere with your drone and in the end be detrimental to a well-functioning drone. All micro drones today have the PDB built into their flight controllers, but some of the larger drones, 5-inch and up, still require a separate PDB. For this reason, the standard size for a PDB is 30 by 30 millimeters. This refers to the distance between the standoffs on which you will mount your other components inside your frame. The functions of PDBs are instrumental in keeping your drone safe and regulated. Whether your PDB is a separate board or integrated with your flight controller, the need for reliable, stable, and clean power is essential to having clear signal and protecting components. Let's look at the next important part of your drone, the electronic speed controller. This vital drone component takes power from your battery and a signal from your flight controller and translates that into the rotational motion of your motor. Every drone contains one ESC system for each motor used. Without an ESC, motors would only be able to turn on or off, and changing the speed of their rotation would be impossible. Because multi-rotors rely on constantly changing motor speeds, an ESC is required to convert the battery power and flight controller signal into motor movement. ESCs are rated based on how much current they can pass to the motors. Because the job of the ESC is to switch on power to the motor coils at an incredibly fast rate, ESCs can burn out if they are not rated to handle the load put on them. The switching is controlled by a microprocessor and carried out by transistors called MOSFETs, which stands for Metal Oxide Semiconductor Field Effect Transistor, but they are more commonly referred to as FETs. The size and quality of these FETs determine how much current can pass through the ESC. ESCs will have ratings such as 30 amps or 25 amps, and these numbers generally represent the sustained current the ESC can handle. For short periods of time, generally less than 10 seconds, ESCs can handle slightly more current. It is common to see an ESC labeled as capable of handling 30 amps with a 40 amp burst. The amp rating is an important consideration when purchasing an ESC. It is far better to get an ESC capable of more current at the cost of size or expense versus an ESC that might be damaged by a larger current. Electronic speed controllers are an essential part of your drone and work hard to control the raw power coming from your battery. Selecting an appropriate ESC is vital to a well-performing drone. Make sure you consider your motors, propeller size, battery, and end goal for your drone as you select an ESC. Let's look at your video transmitter next. Video transmitters, or VTXs, are really what ties the whole FPV experience together, as their primary purpose is to provide low latency video from the perspective of your drone to your goggles or monitor so that you can maneuver the drone without crashing. Whether you're using an analog or digital system, VTXs output video at a specified power rating. This power rating is in units of milliwatts, and the higher the value, the more range and penetration your VTX will be capable of. For close range flying in open air, 25 milliwatts is sufficient, but for flying long range in mountains or at abandoned buildings, power ratings of between 800 to 1000 milliwatts are desirable. The typical frequency for most VTXs on the market today is 5.8 GHz. This provides ample range and penetration for most purposes. However, there are video transmitters available in different frequencies for various specialized purposes. But just because a VTX uses the 5.8 frequency doesn't mean that it is outputting video at exactly 5.8 GHz. Instead, VTXs are configurable within a small spectrum of frequencies. Typically, these fall in the range of 5.645 to 5.880. These numbers are used as channels to enable multiple pilots to fly at the same time without interfering with each other's signals. All VTXs and air units use antennas to transmit the video signal back to your goggles. There are multiple considerations when selecting an antenna. The first thing to consider is the connector type. Antennas are made from coax cable, which is wire that contains an inner conductor surrounded by a conducting shield. There are various types of coax connectors, the most common of which is SMA. You may have seen SMA-style connectors used in old TVs. Most antennas will use SMA connectors. However, for a VTX board, these are quite large. There are other small coax connectors that are used more frequently on VTX boards. The most common ones you will see are U.FL, U.FL IPEX, and MMCX. These are all very different, and it is important to know which kind of connector is on your VTX. Often pilots will use what is called a pigtail to convert between one of the smaller coax connectors to an SMA-style connector for their antenna. One more distinction to be aware of is the difference between SMA and RP SMA connectors. The difference is whether the center connection is male or female. In this image, you can see the difference between SMA female and male and RP SMA female and male. As long as you are aware what kind of connector is on your VTX and that your antenna uses, you can select the correct pigtail to match the two. When selecting an antenna for your VTX, it is important to understand the difference between circular polarized and linear polarized. Polarization in this instance refers to the way a signal travels through space. In the case of linear polarized antennas, the signal path is in one plane only, whereas for circular polarized antennas, the signal path is in the vertical and horizontal plane like a spinning corkscrew. If our drones were flying in one direction only and doing no flips or rolls, a linear antenna would be best for long range because all the signal is focused in one direction. However, FPV drones were designed to be acrobatic, so linear antennas don't work well for long range. The next thing to understand is direction for the polarization in antennas. Typically, you will see directional or omnidirectional antennas. Omnidirectional antennas essentially transmit video signal equally in all directions, whereas directional antennas send the video only directly away from the antenna. Directional antennas work great if they can be pointed directly at the target. However, again, with FPV drones being acrobatic, this does not work well for most purposes. Most antennas used on drones will be an omnidirectional antenna. Another method to enable more people to fly at once is using right-hand or left-hand circular polarized antennas. This essentially references which direction the corkscrew shape is going that we discussed earlier. Video transmitters are vital to a successful FPV experience, and proper selection and pairing of VTXs and antennas can make a huge difference. Let's look at the FPV camera next. FPV cameras capture and send the perspective of your drone to your goggles with as low latency as possible. All cameras use sensors to interpret the light or photons into a digital or analog signal. For FPV cameras, the two sensors you will see are CCD and CMOS. CCD sensors are a bit older technology and for many years performed much better than CMOS. CCD sensors have very low latency because the video they send is not as crisp as CMOS sensors. They also have a good wide dynamic range, or WDR, meaning that they can adjust well to varying degrees of light and shadow without over or underexposing the image. However, CMOS sensors have continued to develop and in the recent years have been able to produce video at a lower latency than even some CCD sensors with increased sharpness of image. In most cases, new cameras with CCD and CMOS sensors will be fairly similar, but some pilots prefer one sensor over another because of the look. FPV cameras use a measure called TV lines, often abbreviated as TVL, to specify the definition it can provide. TVL is essentially a factor of how many black and white lines can be recorded and processed at a time. The higher the TV line number, the more definition a camera can process. FPV cameras will have TV line values as low as 600 and as high as 1200. However, it is worth mentioning that just because you have a camera with twice the TVL value doesn't necessarily mean that you will get twice as crisp of an image. There are also limitations on your goggles, and even some camera manufacturers will even claim a higher TVL than the truth because there isn't really a great way to measure it. NTSC and PAL refer to resolution and frame rate settings a camera can use. Most cameras today are equipped to be set for either of these presets. PAL video has a resolution of 720 by 576 at 25 frames per second, while NTSC video has a resolution of 720 by 480 at 30 frames per second. If you prefer a slightly better resolution, you will choose PAL. If you want a more fluid picture, NTSC is the best option. FPV cameras are extremely important to your drone build, and it is valuable to understand all the various options and metrics available to you, but it will likely take you a bit of time to decide what configuration you prefer. Most cameras available today will do an exceptional job, so the most important thing is that you get one that can give you the best flying experience for you. Now, let's look at the radio receiver. The radio receiver, or RX, is what receives the signal from the transmitter and tells the flight controller what to do. They are generally small and can come in a few different shapes and sizes with several different features. There are generally two types of RX. A cased RX has a plastic shell or cover. These tend to be bigger and often have multiple connections for servos and electronic speed controllers. They are mostly used on fixed-wing aircraft. A bare RX has no case. These are generally smaller and are often covered in heat shrink or plastic film. They are lightweight and easy to mount in tight spaces on your drone. They normally have fewer connections and are geared more towards drone use. Both of these can have various other features such as telemetry and diversity. A telemetry RX has the ability to send data back to the controller. That data can contain many things like drone battery information, signal strength readings, and even GPS coordinates of the drone. A diversity RX has two antennas or receivers built into one unit. This is a feature for redundancy in that if one receiver loses signal, the other can take over. On top of this, some RXs have connectors for different antenna options to help increase range. Most modern RXs operate on 2.4 GHz frequencies. This normally gets you plenty of range when flying in parks and open areas, though range can vary greatly depending on flying location and equipment. Normally, you will be able to get up to 1,000 feet or more of range out of a 2.4 GHz system. If you want to extend this distance limit, you will want to upgrade to something like a Crossfire system that can easily send your drone several miles while maintaining a strong connection. Now, before we jump into what you need with you to control the drone, there is one last very important part of the FPV flying experience, and one shrouded in confusion and fear: the LiPo batteries. The most common battery chemistry used in drones is called lithium polymer, or LiPo for short. LiPo batteries have a high energy density and high discharge rate, meaning for their weight and size they can store a high amount of energy and deliver a lot of power. This is what makes them so popular in the droning world. Now, there are some specific terms and values that are important to learn about LiPo batteries that will help you understand how and why we use them. First off is voltage and capacity. Voltage is a measurement of potential energy between 2 points, in this case being the positive and negative terminals on a battery. A standard fully charged AA battery has 1.5 volts. On the other hand, a fully charged LiPo cell has 4.2 volts. When you put multiple cells in a chain or series, you increase the overall voltage. Cell count, or S for short, is the number of cells that are in a battery pack. A cell is simply a package or container that houses the conductors, chemicals, and insulators that make up the battery. How many cells your battery has determines what voltage a battery pack will be. For example, a 1S battery will consist of only one LiPo cell and at full charge have a voltage of 4.2 volts. A 4S battery will have 4 cells and at full charge a voltage of 16.8 volts, and so on. Battery capacity is a measurement of the charge stored in a battery. This charge is measured in amp hours, but in drone terms, we usually use the smaller form of amp hours, milliamp hours, or mAh for short. A mAh is equal to 1,000th of an amp hour, and an amp hour is a current of 1 amp flowing for 1 hour. So if you have a 1 amp hour or 1000 milliamp hour battery with a 1 amp load, the battery will last for 1 hour. In the case of charging a battery, a LiPo cell with a capacity of 1000 milliamp hours or 1 amp hour can store only that much at full charge. LiPo batteries also have something called a C rating. This is a rating of how much current or power the battery is capable of delivering at any given time. You must also keep in mind that C rating and capacity go hand in hand. For example, a 1500 mAh 100C battery will be able to supply more current than a 1300 mAh 100C battery. A battery with a C rating of 100C is capable of delivering 100 times the mAh rating of the battery. So if you have a 100C rating and a 1300 mAh battery, you take the product of those two numbers, 100 times 1300, which equals 130,000 milliamps or 130 amps. Here is a real life example. I fly my drone at around 20 to 28 amp continuous draw, and occasionally on flips, tricks, or full throttle punch-outs, the drone will draw up to 100 to 120 amps. So I need a battery that can deliver 120 or more amps. In that case, I would need to fly with a 1200 mAh 100C battery at minimum because it can deliver the amps I need. Owning a LiPo battery is kind of like being Spider-Man. With great power comes great responsibility. LiPo batteries can be very dangerous, and this was just a basic rundown of them, and we didn't even really address LiPo battery safety at all. Make sure you are up to date on LiPo battery safety before buying your first ones. Now that you know all about what is on the drone itself, let's jump into everything you need to operate the drone from the ground, starting with the transmitter or controller. A radio RC transmitter, or TX for short, is a device that will translate inputs such as switch and stick movements into radio waves that are then received by your drone's receiver and translated into aircraft movement. TXs use a system of channels to control the aircraft. A basic setup would be one channel controlling the throttle, one channel controlling pitch, another channel controlling roll, and so on. Most FPV drones use up to 6 channels for controlling all the different functions on the drone. For this reason, you want to make sure you choose a TX that has at least 6 channels. Most on the market have options between 8 to 16 channels, with some offering even more. Both the TX and receiver need to be operating on the same frequencies and protocols in order to operate correctly. Most modern day radios run in the 2.4 GHz band and use digital protocols to encode the signal to reduce the risk of interference and signal interruption by another pilot or a radio source. 2.4 GHz does have limitations though. Past 0.4 miles, you start to run the risk of losing signal. That is why a lot of pilots that fly longer range prefer to use long-range modules like the FrSky R9 or the TBS Crossfire on their radios. These allow you to transmit on 900 MHz frequencies. This allows the drone to fly a mile or more away without losing TX signal. Protocols are kind of like the language that the TX talks to the receiver with. For example, if your TX is not transmitting within the correct protocol, even if the signal reaches the receiver, it still won't be able to understand it. So both the TX and the receiver need to be on the same protocols to work. A general rule of thumb is that each brand name of radio has its own protocol, so therefore you're going to want to stick to one brand of radio and receiver and also one frequency. For example, a 2.4 GHz transmitter must be paired with a 2.4 GHz receiver, and so on and so forth. Let's look at FPV goggles now, the defining factor that modeled FPV into what it is today. FPV goggles are one of the most important pieces of equipment you will use when flying. They are what give you that immersive experience of becoming a virtual onboard pilot of your drone. They are made up of a portable screen or set of screens that you strap over your eyes and enable you to see the live video feed from your drone. They have either built-in video receivers or video receiver modules that can be installed to receive video signals. There are 2 main types of goggles, box goggles and binocular. Box goggles usually consist of an enclosure that is formed to fit around your eyes and has a single rectangular video screen that sits a few inches away from your eyes. These often have a lens to help your eyes focus on the screen. There are a few benefits to box goggles, but first and foremost is the price. Box goggles can cost as little as $50. They also often work better for people that wear glasses, as you can oftentimes keep them on while wearing them. They are also sometimes easier to use because of their built-in rechargeable batteries and easy to find controls and buttons. The main drawback to box goggles is the size. They are often large and bulky and might not be as comfortable as other goggles. Because of their size, they are sometimes cumbersome to transport or fit in a bag. But they are great for beginners or even advanced pilots and are very cost effective. Binocular goggles are the most popular style of FPV goggles. They are smaller and more compact than box goggles and often have more features. Instead of one video screen, they use 2 smaller, more specialized screens and separate lenses to focus and magnify the picture for each eye. Even though the screens are smaller, you can still get a large field of view. Some can also be adapted with corrective lenses to negate the need for glasses. One of the main downsides to binocular goggles is the cost. They are much more expensive than box goggles, but have a smaller size and sometimes have better resolution than what you can get in a box goggle. Most goggles will have ratings on them talking about FOV or field of view. FOV refers to the measure of how large your view is on the screen or how much of your surroundings you can see. Another rating is aspect ratio. Aspect ratio is the ratio of a screen's width to its height. A lot of newer goggles will come with 16:9 standard, as opposed to the older standard of 4:3. 16:9 gives you a wider display, but 4:3 allows you to see more on top and bottom. Most FPV pilots use what's called analog video with their goggles. This means that the video receiver in the goggle receives video signals much like an old school TV receives video. There's a carrier wave transmitting at a certain frequency, in this case in the 5.8 GHz range. It then gets modulated with the analog video signal, then sent out of your VTX antenna. Your receiver then picks this up, demodulates it, and displays the video on your screen. Digital signals operate in much the same way, except that the carrier wave carries 1s and 0s that get decoded on the receiving end and displayed as video in the goggles. What this boils down to is that with digital video signals, you are able to transmit a lot more information, which equals better video quality. With analog, the video quality is good, but it is incapable of handling HD video. Both systems have pros and cons. Analog systems are readily available and there are less expensive options that work well. Digital systems provide outstanding HD video quality, but come at a higher price and usually lower range. Analog systems have a greater range and are usually quite a bit cheaper, but they limit your visibility. It really comes down to what you need them for. Most goggles on the market today have a scanning function that can automatically find and lock onto the video signal from your drone or someone else's drone, assuming they are on the same analog or digital system. On most goggles, you have what is called a diversity system. This means that there are two video receivers that receive the same signal. This lets you put two different kinds of antennas on your goggles, like a directional and omnidirectional antenna. The benefits of doing this are increased range in one direction with the directional antenna, so long as your antenna is facing that direction, and the omnidirectional antenna that will work well in a closer range or if you fly overhead or behind yourself. This gives you the best of both worlds. In conclusion, video goggles are an important part of your FPV system and should be purchased with care. It is advisable to invest in a good pair that will last a long time and give you all the features you need. Okay everyone, so that concludes the What is FPV section of this training and what you need to know about the parts and components of it all. Once again, this was just an overview of everything. We just cannot cover everything you will need to know in one training sit down as much as we would like to. FPV takes an incredible amount of hard work to learn, and that's why we put this training together, so you guys could have a great starting point to your learning experience. We didn't even touch on topics such as assembling your drone, configuring it and your controller, learning how to fly, do tricks, race, tune, edit FPV footage, or any of the other dozens of topics needed in FPV. There's just so much information needed in order to get into FPV. Real quick, I want to jump into my top 5 tips before and during your FPV journey. These will hopefully save you money and time as you move forward. Tip number 1, start in a simulator first. You need to start practicing flying before you buy your first part. This is best done in an FPV simulator. The one I recommend is Liftoff, which can be found on Steam. Its graphics are very good and I have found it to transfer very well to real-world experience. You can even play it with a game controller such as a PS4. I started out doing this and it taught me a lot, but I would recommend playing it with a controller more suited to what you'd actually be using in FPV, such as a Taranis QX7. Simulators will teach you the basic stick movements that you need to learn in order to fly your drone. You can crash all you want and not have to worry about repairs. It will help you learn throttle control, how to hover, forward flight, using both sticks simultaneously to turn, and many more skills. Tip number 2, learn how to build and repair a drone. Unlike many hobbies out there, FPV is a very hands-on one. You need to be willing to assemble or repair your drone. This will usually require some learning into the world of electronics, soldering, engineering, and the like. You don't need a PhD to assemble a drone, but having a good understanding of what cord does what and goes where will save you lots of time when you are out in the field and your drone won't work properly. Tip number 3, learn how your parts work. To tie into the above tip and this entire training, you will understand much more about FPV and what is best for your drone when you understand how the drone works. For example, understanding your prop's pitch or your motor's KV rating will help you not make a mistake in ordering a prop that would match poorly with a motor or buy a battery that would put too much strain on your motor. We taught you a lot in this training, but there is always way more to learn, which is why we made our course, which teaches all of this and much more. Tip number 4, take it slow. FPV really is not a hobby you can rush into. Even after an initial deep dive into learning about FPV, there are still many things that can only be learned from experience. This is super important. Don't make the same mistake I did when I started. I got too comfortable, too quick, and lost a $600 investment within the first month of owning it. Take things nice and slow and slowly expand your abilities. Don't rush into flying gaps or doing cool flips if you haven't mastered throttle control or learned the limits of your yaw. You will crash in FPV, you will lose drones, but you will fix and you will find. The best prevention for user errors is to practice and take it slow. Tip number 5, fly with a friend. I honestly cannot say how important this is. Now I know a lot of people will not always have someone to fly with, but as you are starting out, it is always best, and technically legally required, to fly with someone else who is keeping an eye on your drone and will let you know of any issues they see, such as flying behind large objects and out of view, and help you find it in case of a crash. Probably 90% of my FPV flights are done with other FPV pilots, so we can help spot for each other and give each other input on our flying skills and improvements we may need. As an added extra tip, number 6 would be Be careful with whom you trust. There are lots of forums and FPV Facebook groups out there that can offer tons of help and opinions. However, as more and more people get into FPV, the opinions and people you can trust to give you reliable information decreases and gets muddied in the ever-churning waters of public and private opinion and the need to be right. But I'm not saying don't ask for advice on forums or groups. Just make sure you come armed with some salt, because not everything you read will be valuable, correct, or even important. It's for this reason we have a private Facebook group for our students where they can ask questions and their peer students or we mentors can give answers that actually apply to them and what they need. So now I want to dive into FPV Unlocked and give you an idea of what the full program includes for anyone who enjoys my teaching style, has gotten a lot of value out of this webinar, and would like to learn a whole lot more. Again, this training is only an hour long, and the FPV Unlocked course is over 7 hours of video content, and we're adding more content to it every week. So as far as content goes, here's a quick look at the topics I cover. I have a full section dedicated to explaining in depth everything you need to know about the subjects we talked about today and many more. We go over every aspect of the FPV gear to give you a well-rounded understanding of all the parts and electronics needed. This section gives you the knowledge you need to start making the right choices on what you want out of FPV and save you money and time in not buying the wrong parts for the wrong build. The next two sections cover everything you should buy and how to assemble it into a working drone. We take you through step by step on how to build an entire drone from pieces. We give you the techniques and tips we have used on dozens of drones to give you the best assembly experience possible. We focus on building the Emax Hawk Pro in the course, which is a great, well-rounded drone for racing, freestyle, or cinematic uses. This also allows you to follow along with the exact same drone we're using. In our fourth section, we bring you into configuring your drone through software on your computer, in this case, Betaflight. We show you how to navigate the platform, what the settings mean, and how to set up your drone to avoid common mistakes made by new FPV pilots. In our fifth section, we jump into the flying. Here we start from the beginning in a simulator, walking you through the techniques and practices you should begin work on to start boosting your confidence and skills. Then we bring you out on your first flight, what you should be looking for, what you should do, and what you can expect. We do these videos out in the field so I can give real-time instructions while flying to give you a grasp on how you can make your first flights a true success. In our sixth section, we jump into freestyle. Here we teach you the tips and tricks to perform the best you can when doing tricks in the air with your drone. We also plainly walk you through performing several tricks in the simulator so you can practice along and get comfortable with them before going out and doing them with your real drone. In our next section, we go into tuning. Here we teach you the basics of PID and rate tuning. This topic in the FPV world is often misunderstood or even more daunting than the rest, if you can ponder such a thing. But here we break it down and explain and guide you through it so you can not only learn how and why it works, but how you can transform the same drone from a racing drone into a freestyle drone, then into a cinematic drone, all based off of tuning. Believe me, this is a section you do not want to miss. We also have other sections of the course that are being developed to continue to provide the best experience to all of our students. This includes live training, where we go out with students and give them live training on how they are flying or performing other tasks related to FPV. We will have a section on how to edit FPV footage, where I condense years of professional videography to teach you how to get cinematic footage, color grade it, and edit it into fantastic videos. Gear reviews, where we look at new advancements and products in the FPV community and give you guys the knowledge to make good, educated purchases. Other modules we are working on include ones on racing, cinematic FPV drones, Cinewhoops, and so much more. As I mentioned earlier, I credit a lot of my growth in FPV to the fact that I had McGregor as a mentor along with the circle of pilots he knew to answer my unique questions. So with this course, you will have myself, McGregor, and others to be your personal mentors. We will answer any questions you have and help you along your way. Even more valuable than that personal mentorship is our Facebook group, where you can join all our other students in seeking help and advice on different topics surrounding FPV. As we mentioned earlier, this group is centered on helping people and focuses on that instead of dozens of individual opinions that are weighted against each other, which creates a lot of unnecessary conflict. We are very focused in this group on providing value in this group and helping people. We also provide a map for all our students to share their general location so you can schedule meetups and get-togethers to fly with other FPV Unlocked pilots. The Facebook page is also where we host contests and review your videos and give feedback. You can send in your FPV footage and we will help you tune in your flying skills and abilities and also give advice on how you can get better footage. Also, as an added bonus, we do live meetups where you can come along with us to fly, do some freestyle, race, or just enjoy the show and watch. We also film these events so that if you couldn't make it, you can still feel like you did. And a few more bonuses we offer is a 10% off discount to Emacs USA, so you can get all the parts you need to build your first drone for 10% off. We also offer a discount to HTRC LiPo battery chargers, which are the ones we recommend in the course. We are working on more deals with other FPV companies as well, and our students are the only ones who can get these discounts. We also give you a list of everything you need to buy to get started in FPV and follow along in the course. So there it is. That is what FPV Unlocked includes. It is a lifetime membership, so there's only one upfront cost, and you will have access to all the current content and all future content for life. You can watch at your own pace on your phone or your computer. This course will save you so much time, and to show that, here are a few reviews from students who have already taken our course. Jeff McMurray said, "I'm extremely green in FPV and tired of endless hours searching online for answers. I just made the pre-order purchase. I'm loving it. Looks professional and no off topics to make videos forever long and making things confusing." Joshua Goodwin said, "FPV Unlocked is jam-packed with content that is easy to find. For someone just starting going through this course gets me even more excited to get out and fly. The videos are well done and well explained. 2 thumbs up." In the end, with FPV, you don't know what you don't know. That's why a course like this is so important. You could study and research all day for FPV, but then go out and miss one important factor that crashes your drone. This is what we try to avoid for our students. We want to arm you with what you need to know so that you don't make these mistakes. So without further ado, we will finally get to the price of the full program, and as promised, I'll be offering an exclusive webinar discount for those of you who have hung around to the end of this training. This program is valued at $997. But as a special price, we have lowered it to just $297. Or for those who cannot afford the upfront cost, I have a 6-month payment plan of $60 a month as well. But as an even better offer, as a webinar discount only, the first 5 people to join in the next 15 minutes will get an additional 25% off by clicking on the link that just popped up below. The link is down below for the payment plan or the full upfront cost. Click it and it will open a new tab with the discount already applied. Again, this is a limited time discount, so if you are thinking about joining, now is the time. And while that offer is ticking, I will be answering some of the top questions I get asked about FPV and our course. Okay, let's jump into some questions. Why would I buy this course when I can just watch free YouTube tutorials? That's a great question. As we've talked about, the alternative to FPV Unlocked is spending hours and hours sifting through YouTube looking for good tutorials. Now, I'm telling you from experience, I personally took the YouTube route, and the biggest problem I faced was you don't know what you don't know. So I'd watch a bunch of tutorials, go out and try and apply them, then realize I made huge mistakes because I wasn't getting all the information I needed. I'd then go back and search for more tutorials on that topic, and this can go on for months or years, learning through trial and error with a lot of error. With FPV Unlocked, we've condensed hundreds of hours of YouTube knowledge and years of learning from mistakes and packed it all into one chronological course that you can watch in one day. Time is money, and this course saves you a bunch of it. Next question, what gear should I buy? This is obviously one of the biggest asked questions I get, and the answer is difficult. Obviously, there are different drones for different jobs, but if you want to start with a drone that will suit you well as a beginner and be able to maximize its abilities into other areas of FPV, I recommend the Emacs Hawk Pro 2400 kV. This is the first drone we teach in the course, and we have fine-tuned it into a racing drone, a freestyle drone, and a cinematic drone. As far as goggles and controllers, we recommend the Taranis QX7, not ones with access, and the Eachine EV800D goggles. These are a good budget controller and goggles that give you lots of room to expand. One of our pilots, Clark, has been flying professionally for clients with this controller and goggles since the beginning. For batteries for this drone, we recommend the RDQ 1300 mAh 4S batteries. These batteries perform very well for all types of uses with the Emacs Hawk Pro. Remember, these are just recommendations. You may have different needs and things you need to accomplish, but this is what we teach as your first go with FPV, since it gives you a basic understanding of how FPV and the parts work, but also sets you up to start doing advanced things like tuning and freestyle while still using the same drone. Definitely a good investment, especially if you join the course. And just a quick FYI, if you want to see all the stuff I recommend, feel free to go to www.kit.co/Jacob Howard. Next question, should you buy ready to fly or build it yourself? There are benefits in both options. Let's talk about these. Buying a pre-built drone is a great option. You get it nicely packaged in a box, and in most cases, all you need to do is install the props, bind or set up your transmitter, and you're good to start flying. However, if you crash and something breaks, what now? That's where building your own drone can come in handy. When you build your own drone, you gain detailed knowledge of how the drone is put together and what components do what and how they work together. So when it comes time to replace a broken component, you're already that far ahead of the curve in knowing how to disassemble and replace parts. Plus, building can, for some people, be a fun part of the overall experience. Next question, what's the startup cost of FPV? This can vary greatly for each person. Generally, the drone itself is going to cost you between $150 to $300. The controller will cost you anywhere between $100 to $200, and the goggles can be as cheap as $50 all the way to $600. Batteries will cost you about $15 to $60 each, depending on which one you buy, and the chargers can go from $50 to $300. Other accessories like assembly tools, GoPros, mounts, extra props, and many more can run the hobby up several hundred. In most cases, I'd expect to pay at least $500 to $750 for your first go, and all the way up to $1,500 to $2,000 for more advanced ones. In the course, you can expect to pay about $700 for your first drone setup. Next question, how long will I have access to the course? Can I rewatch videos? You will have lifetime access to the course, and you can rewatch any video you'd like as many times as you would like. Next question, do I have to use the same drone, controller, goggles, configurator, etc. as you to take this course? Although we recommend you get the equipment we recommend so you can follow along, it is not required. We teach a lot of principles and best practices in this course that will transfer well to any equipment you decide to use. We have several students who build other drones with the knowledge we give them, and they love it. Next question, is this course only for beginners? Absolutely not. We have had people in FPV for over a decade say they learned so much from this course and what is taught. We don't just give basic information. We give detailed explanations of even small things that you may not think are important, but really are. The goal of this course is to bring you from knowing nothing to knowing more than most professionals out there. So even if you have years under your belt, there's always more to learn. Next question. Do I need separate drones for different styles, such as freestyle, racing, cinematic, etc.? This can really depend. Yes, getting a drone designed specifically for racing is going to be your best option. Same goes for freestyle and cinematic. However, drones like the Emax Hawk Pro can easily be tuned to accommodate different flying styles. For example, in our course tuning section, we show you how you can tune a drone like the Hawk Pro that is mostly meant for racing into a freestyle drone by adjusting the rate tune. This controls how the drone reacts to the stick inputs. We also took the same drone and turned it into a cinematic drone by applying the same principles of rate tuning. This is super valuable information and why our tuning section in our course gets a lot of attention. Next question. What beginner drones do you recommend? If you want to start really small and expand your FPV experience from there, I recommend starting with a drone like the EZ-Pilot. This drone has 3 modes that allow you to slowly get better at flying. It also comes as a complete set with controller, drone, battery, charger, and goggles for all under $100. A super good price for a super fun experience. Speaking of a super good price, just wanted to remind you that we are about halfway through the time left on our offer. We got quite a few purchases already, so we decided to extend our offer for you guys still on the fence. Click the link below to get the deal now. Okay, let's jump into a few more questions before I have to go. Next question, can I use the private group to buy and sell gear? Yes. Of course, we do monitor and keep track of this to make sure people don't get scammed, but you are allowed to sell your gear, but we always ask that the highest of moral standards are adhered to. Next question, how do I know what areas I cannot fly in? As droning becomes a bigger thing, understanding where you can and cannot and shouldn't fly is a good idea. To give a quick run over, here are some basic ones to remember. You can usually fly in state parks with a permit. You cannot take off or land within national parks. You cannot fly after dark without a waiver. You cannot fly more than 400 feet above or next to a structure, which includes mountains, buildings, etc. You cannot fly within 5 miles of an airport except with permission. You cannot purposely fly directly over people or moving vehicles. There are several other laws and restrictions, but most of them can be found in general with a pretty easy search. We also recommend people get an app like Kitty Hawk or AirMap that can show you exactly where restrictions are before you go on your flight. Next question, how far will I be able to fly with my drone? Well, on a standard controller and receiver, you can usually get anywhere from 1,000 to 4,000 feet away from where you are. Usually, if you want to start flying long range, you need to outfit your drone with a long range system. This includes long-range modules such as Crossfire and other safety features like beepers and GPS, so you always know where your drone is, and even set it up to return to the general area it took off from if it gets disconnected. The thing to remember with FPV drones is that usually, if you lose connection, the drone falls from the sky. So you want to make sure you can outfit your drone with a long-range system if you want to do long range. We have tested the Emax Hawk Pro that we teach in the course with a long-range Crossfire system and GPS, and we've flown over a mile away with the stock VTX and antennas that come with our goggles. So it can definitely be turned into a long-range drone. Next question, how do I get good FPV footage? This is a topic we plan to explore in depth in our course, especially since I have years of experience doing video work for multi-billion-dollar companies around the world. A few things I'd recommend for a GoPro Hero 7 Black setup are as follows. You'll want linear view, ProTune on, 2.7K at 60 frames per second, stabilization on, shutter at 1/120th, min ISO at 100, max ISO at 400, sharpness on high, and color on flat. ISO is the GoPro trying to add light to the image, which makes it more grainy. So you want to set the min to the lowest and the max as low as possible while still getting good exposure in darker areas. A shutter speed at 1/120 will also give you a natural motion blur to your image that will make it look more realistic. Next question. If I have specific questions, would I be able to email you those questions? For sure. You can send me an email at jacob@fpvunlocked.com or to m.me/fpvunlocked, and me or someone from my team will get back to you as quickly as possible. Speaking of questions, I hope I've answered most of yours in this training. If I didn't, feel free to contact me at the aforementioned contacts. Also, if you have any other questions or doubts about whether this program is right for you, shoot me a message. I'm super accessible. Let's chat about your situation and see what we can do to help. Anyway, our offer is officially coming to a close. So procrastinators or people having payment issues, hit me up at jacob@fpvunlocked.com if you still want that discounted price, and we'll get you taken care of. Other than that, I'm going to head out. If you guys want, you can follow us on Instagram, Facebook, and YouTube, all at FPV Unlocked. I wish you guys all the best of luck in getting started in FPV, and as always, if you have any questions, definitely let me know, and have fun flying.